Hello, this lecture 7E will cover a closer look at creating present state to next state tables. Before we continue on with state machine design, what I'd like to do is zero in a little bit more on this present state to next state table. It turns out that this is not new lecture material, but it's going to give you insight into how to work these problems as we a little bit better when we go into these the homework and progress through the next week or so. If you remember back on page 210 in the lecture notes, we talked about synchronous logic design procedure. And we said if you followed this design procedure, it would get you to a final realization of a synchronous logic circuit. If you look at step number two said you come up with a state transition diagram, and I told you that once you get that state transition diagram, it's all procedural right through the realization of your design. But in the third step, you wanted to construct a present to next state table. Well, you create that present state to next state table from your transition diagram, but I'm going to look a little closer at the present to next state table. Do you remember when I told you on page 218 when you're designing state machines, and I said this was important back then, that if you take a look here at your block diagram, you're going to have some external inputs that influence the circuit, that control the circuit, and you're going to have feedback coming from your sequential logic, which is your flip-flops. You might have one flip-flop, two flip-flop, three flip-flops, and so on and so on, but for every flip-flop you could have a line being fed back here as an input. And the total number of inputs you have, your external inputs plus your feedback inputs, tell you what variable map you'll use. I mentioned that to you. So what we're going to do here is we're going to take a look, and you don't have lecture notes, you just have to stop the video or look at what I'm showing you here. But let's pretend we're designing a synchronous logic circuit, and we have two external inputs, A and B, and we need potentially two states. So that's just one flip-flop. So we're going to have a Q0 term coming back. So we have a total of three inputs. Notice that three inputs means we're going to use a three-variable map. So down here at the bottom, I'm going to have a three-variable map that we're going to work with. Three inputs up here mean we're going to have a three-variable map to use. All the maps, our final output maps, our next state to present state maps are all going to be three-variable. But the way I set up my present state to next state table is I have my input A and B, both my inputs A and B, and I have my Q0 term, Q0 to the N, that's the present state, N will be the present state. And then my output is the next state. My next state is Q to the 0, N plus 1. Notice here on your total number of inputs, we have two external inputs, but we have a total of three inputs. So you put down your 0, 0, 0, and you number that sequentially through all your possibilities up to 1, 1, 1. There's going to be your 8 possibilities. And notice when you do your K-map here, when you do this K-map, the only thing you have to be careful with is the way you have these labeled up here. If you put your inputs first, that's what I did here. You're going to have A, you're going to have B, just like we did before, but this isn't C anymore. This is called Q0 to the N. This is your present state. It goes down here. So this row is all A input. These two columns are the B, and the two center columns are the A0 to the N. You take that right off your block diagram, or you're taking it right off your headings here of your present state table to next state table. Let's look at another one. This time we're just going to have one input. We're going to have one external input. And when I give you these additional specs through designs 4, 5, 6, 7, 8, 9, you'll see this will be motor on or temperature above 100 degrees. Right now it's A. Okay. Here we have A, and then we have two flip-flops. Why do we have two flip-flops? Because we needed a potential of 4 different states. And you're not going to get 4 states without two flip-flops. So here we have a total, we have one external input, and we have feedback telling us where we were in the state transition diagram as we moved around through those states. Notice that's a total of 3 inputs. total of 3 inputs, you're going to use another 3 variable map. The only difference is A, same as it's always been, but the present states Q1 and Q0, this was your A, B, and C in your other truth tables, but A, here, this row, B is Q1, which is the last 2 columns, and Q0 is what we used to call C. It's the 2 center columns. You just have to be careful how you lay out these maps, and you'll just be fine when you reduce the logic. I want to show you something else here. I don't want you anymore to put Q to the 1 to the N and Q to the 0 to the N, and this is Q to the 1 to the N plus 1, this is Q to the 0 to the N plus 1. Look, we know these are present states, Q1 and Q0. It's defined here. We know this is the next state, so you don't have to put N plus 1. You put Q1, Q0, Q1, Q0. This will define present state and next state. Let's take a look at another example. There's quite a bit of examples I could show you, but after these 4, I think you'll be fine with it. Notice we have synchronous logic design. You have 2 external controls, A and B, inputs A and B, and you have 2 flip-flops here for the reasons I mentioned in the previous one. That's a total of 4 inputs. You have 4 total inputs, so you're going to have a 4 variable map. 4 inputs, 4 variable map. All your maps will be 4 variable. Let's take a look at setting up this present state to next state table. I'm going to take A and the B, which are the inputs, and I'm going to take Q1 and Q0 to define the present state. That's a total of 4 inputs, and I write them this way. So what you do is you go through all the possibilities just like you would in any truth table. These really can be in any order you want. But generally you have the inputs first and then the states, or you have the states and then the inputs. But the thing you have to be careful with is when you go down below, the most significant bit up here gets labeled at this point. The next one here. The next one up there, and the next one down here. Just like the A, B, C, D we did before. But let's take a look at this. You go 0, 0, 0, the whole way through 1, 1, 1. 16 possible states. You go in order so you get all the possible combinations. And you work with all 4 variable maps. And then finally, what if you have a problem like this? It'll be a word problem, but you just boil it down to the block diagram. I told you these block diagrams are important. Here you have 1 external input A, and you have 3 flip-flops. Why do you have 3 flip-flops? Because maybe you needed 8 states, or 7 states, or 6 states, or 5 states. You know, to get that many states, you're going to have 3 flip-flops, or 4. You need 4 states. You still have to go to. You still need to go to. Well, with 4 states, 2 flip-flops would do it. So if you needed 5, 6, 7, or 8, you had to go to 3 flip-flops. That's how many states you found in your state transition diagram. But here, 4 inputs again, total 4 inputs, and here's your 4 variable K-map. But let's take a look at this. What I did in this case is just to do something different. I put the present states first, and I put the inputs second. Remember I said you could do that. It's just going to reflect down here. But let's look at this. I put Q2, Q1, Q0, present state, Q2, Q1, Q0, next state. And you fill all this out from your state transition diagram. I'm going to show you that in the next couple of designs. Pretty easy to do. And these all go together as inputs. There's 4 inputs. You label 0, 0, 0, 0. You treat these all as 4 inputs here. To 1, 1, 1, 1. That's going to be a 16, just like the previous one, 16 possible states. But then when you lay out, when you're down here and you're laying out this K-map, this isn't A, B, C, D anymore. It's Q2. This is Q2. The bottom 2 rows. Q1, the middle 2 rows. Q0, the last 2 columns. And A is the least significant bit, which is the center 2 columns. So I hope that helps you when you go through designs 4 through 9. I think that'll help you. You may want to look this lecture over again. It was only 10 minutes. Make sure you get that, because there was a lot to this lecture that's really going to give you insight through the rest of the synchronous state machine design. That concludes the lecture.